Hubble's mirror was polished with incredible precision, and it still made space look blurry. In 1990, NASA launched the most famous telescope ever built. Hubble floated above Earth's blurry atmosphere, ready to see farther than any telescope before it. Then its first images arrived. Instead of sharp stars, bright objects had fuzzy halos. Distant galaxies looked smeared. The telescope was not broken. It was aimed correctly. Its camera worked. So how could a mirror polished almost perfectly produce a blurry universe? Because Hubble's mirror was perfect, perfectly shaped for the wrong measurement. A telescope mirror is not flat. It is a carefully curved bowl. Light from a distant star hits the bowl, bounces inward, and meets at one tiny point. That tiny point becomes a sharp image. If the curve is even slightly wrong, the light does not meet together. Some light lands early, some lands late. The star spreads into a glowing blur. This problem has a name: spherical aberration. It means the mirror sends light to almost the same place, but not exactly. Hubble's giant mirror had this flaw across its whole surface. But here is the painful part. The mirror itself was polished to an astonishing smoothness. Its surface bumps were smaller than a fraction of a wavelength of light. The problem was not rough polishing, it was the curve. To make that curve, engineers used a testing device called a null corrector. It was like a special ruler made of mirrors and lenses. The device told the polishing machine when the giant mirror had reached the exact shape. Except this ruler had been assembled slightly wrong. One small part sat about 3 millimeters away from where it should have been, about the thickness of a stack of a few coins. That tiny shift changed what correct looked like to the test. Imagine drawing a perfect circle while looking through a bent ruler. You can follow that ruler exactly. Your line can be smooth, careful, and precise. But the circle will still be wrong. That is what happened to Hubble. The mirror was polished with extreme care until it matched the faulty test device. At its outer edge, the final shape missed the intended curve by about 2 micrometers. That is far thinner than a human hair. For a bathroom mirror, it would mean nothing. For a telescope meant to focus light from galaxies, it was enough to blur the cosmos. There had been warning signs. A separate test gave a result that did not agree cleanly with the main test. But the disagreement was not fully resolved before Hubble launched. Then, in space, the error became impossible to ignore. NASA had spent years building a telescope that could see ancient galaxies. Now it could not take the sharp pictures everyone expected. But Hubble had one unusual advantage. It had been designed for astronauts to repair. In 1993, astronauts carried a set of corrective mirrors into orbit. These tiny mirrors were made with the opposite error. They bent Hubble's incoming light just enough to cancel the mistake. It was like giving the telescope glasses. The repair did not reshape Hubble's main mirror. That giant mirror stayed exactly as it was. Instead, the new optics corrected the light after it bounced off the flawed surface. And suddenly, Hubble saw clearly. Sharp stars appeared. Galaxies became crowded cities of light. Hubble went on to help measure the expanding universe, watch stars being born, and show us worlds far beyond our own. Subscribe if you like seeing how tiny mistakes reshape huge stories. Hubble was not a case of careless polishing. It was a case of precise work guided by one wrong reference. That changes the lesson. Accuracy is not enough if your measuring tool is wrong. Every famous Hubble image carries that strange history. The telescope that first saw the universe blurry became clear only because engineers taught a perfect mistake how to cancel itself. And it leaves one bigger question. What other things do we trust because they were measured beautifully but measured against the wrong ruler?